Hello. Right, it's time to stop avoiding the robotic arm. Right, here we go. Right, we want the x-coordinate of this pen. Now this pen, we're told that as this P here moves that way and that way, this angle here at the top stays the same as this angle here. So what will happen is as this moves that way and that way, that Q will swing out like that. Okay, so well, we don't really need to worry about that too much, but we just need to mark on that that's what's happening to help us think. Right, okay. So as that happens, like I say, these two angles are the same. Now, if we drop a little perpendicular down here, what we actually want when we're doing this question is this x-coordinate of Q. This is where the pen is. Okay, so if we draw another one here, you can see we're sort of going around creating triangles now, which is a good idea. Right, let's first of all take this OP and then should we call it, what should we call this? Let's call it L for Louise. Right, OPL. If we look at that triangle there, OPL, label what we know. That's theta and that's theta. So this angle here is 90 degrees. So this side here, OL, will be D cos theta because it's cosy to the angle. Okay, right, so this side length here is D cos theta. Right, now let's have a look at, we want to have a go now at finding, we've got this big length here, we want to find, I think, mine's gone blank, so we've got this bit here, we want this length here. But we're not going to be able to find out that length here, but we can, I think, find out this length here. Okay, so what we're going to do is continue now to drop that down a little bit further. And now we're going to look at this triangle here. Because this distance here, let's call this X. So this distance here, XL, is the same as this distance down here, Q. Okay, so if we draw another right angled triangle to represent this one that we've got here, we've got Q, P, and then let's call this M. Okay, so if we look at triangle QPM, we've now got that this side is D. Now, because that's theta and that's theta, this must be 180 minus 2 theta, or sorry, pi minus 2 theta because we're in radians. So that angle there is pi minus 2 theta. So this angle here must be 2 theta. Okay, now because of the Z shape here, am I talking rubbish? This angle here, this one here must also be 2 theta. Which means, if this angle here is 2 theta, then this one up here must be pi minus 2 theta. Okay, no, it's pi over 2. Sorry, it's pi over 2 minus 2 theta because these add up to 90 degrees, don't they? Right, Georgie, shush! Right, therefore, this side here, QM, will be equal to, this side here will be equal to, this will be D sine of pi by 2 minus 2 theta. Okay, so therefore, if we're looking for side OX, which is what we want the x-coordinate. Mark, you're more noisy than them. Sorry, right, so if we want this x-coordinate here, we're going to have this big side here, which is D cos theta, that big side OL, and then we're going to take away that distance XL to leave us with just OX. So we're going to take away D sine of pi by 2 minus 2 theta. And that's starting to look a little bit like where we want to go. Right. Right. The next bit to realise, and this is the bit that is just beyond ridiculous for 2 marks, is if this is your sine curve, which it is, and let's say the sine of this angle here, so say the sine of, say that's 30, just for argument's sake. Okay, and we did the sine of minus 30. Okay, can you see what I'm doing here? So the sine of 30 will be equal to a half. The sine of minus 30 is equal to minus a half. So we know that the sine of an angle is equal to minus the sine of that angle, the negative of that angle. That makes sense? So we can say that x is equal to d cos theta plus d sine of the negative of this angle, which is 2 theta minus pi over 2. Therefore, we can now factorise that and say x is equal to d cos theta, whoops, not factorise it, plus sine of 2 theta minus pi by 2. And you might think, well, that's absolutely disgusting for 2 marks. And yes, it is. I completely agree.